So hydrothermal vents and seamounts. This is where I personally think that things start to get really interesting. Hydrothermal vents, right, if you don't already know, is a fissure on the seafloor from which geothermally heated water discharges. This means that it's basically like a little chimney on the seafloor where incredibly hot water, we're talking like 400 degrees Celsius hot water, so way beyond the boiling point, is spewing out of the ocean floor. And it's geothermally heated. That means that it's heated from heat within the earth, right? That means that they're commonly found near volcanically active places like a mid-ocean ridge where tectonic plates are moving apart, or a hot spot where there's this mantle plume that's welled up. But anywhere really, really hot magma is close to the Earth's surface that can heat the water within the crust, cause that water to move upward, right? Because hot water has a low density, and spew out of these hydrothermal vents on the seafloor. And these hydrothermal vents can take a variety of sizes and shapes and forms, right? So they can be really, really tall and solitary. Here's an example of just one really tall hydrothermal vent all on its own. It can take on different colors. So here are what we call white smokers, and notice there's a field of them. They're all together. And hydrothermal vents are not these desolate places because they're so hot that life can't survive there. They're actually thriving habitats on the seafloor. When you look at the rest of the seafloor, especially the abyssal plain, there's really not much life going on down there. It's a very quiet, desolate place until you get to these hot spots of life, such as hydrothermal vents, and you get this rich, unique, vibrant ecosystem thriving in this really extreme environment. Extreme because the water is incredibly hot, extreme because there are lots of what we would consider toxins in the water. We could absolutely not survive down here. Extreme because there's no sunlight, it's pitch black, and yet we have these thriving communities. So as I said before, fluid temperatures can reach 400 degrees Celsius. That's 4 times the boiling point. However, the water doesn't actually vaporize. It doesn't turn into a gas because the immense pressure keeps it a liquid, right? So even though it's above the boiling point, it doesn't actually vaporize. And these vents, I know you can't really see it in these images that I'm showing you because it's hard to see scale, but these vents can be enormous. They can grow 55 meters tall. That's the height of an 18-story building, right? So these, when I say chimney, I really mean skyscraper. Like these skyscrapers on the seafloor are spewing out this hydrothermal toxic fluid and hosting these really interesting ecosystems. So recall, true or false? The water around hydrothermal vents does not vaporize because the temperatures remain just below the boiling point.